The big fundamental shift that we're trying to drive, and it is happening in cement more broadly as well, is people are looking at this family of materials Simon calls supplementary cementitious materials. So these are materials that act and behave like cement, but only when they're mixed with the cement in the first place. So, what we call cement in the normal world today is primarily limestone that's been baked at 1500 degrees Celsius. And when it's baked, it gives off a lot of CO2. And what you're left behind with, the calcium oxide, makes the heavy majority of our cement. And so for every ton of cement that we make today, by and large, we're emitting about 700 to 800 kilos of CO2.
Welcome to this week's episode of Leaders on a Mission, where I'm joined by inspiring leaders really driven by the impact of creating a healthy and sustainable world. Now, in today's episode, I'm joined by Apoorv Sinha, CEO of Carbon Upcycling. Now, Carbon Upcycling are a pioneering climate tech company based out of Calgary, Canada, using CO2 as a feedstock really to produce more sustainable products. And Apoorv, I know you're a very busy man. I just wanted to seriously extend my thanks for you coming on the show today.
Absolutely, Simon. It's a pleasure to be here. Thanks for having me.
Great. What has really, I suppose, from a professional viewpoint, really kind of shaped who you are?
Yeah, it's a good question, Simon. I've had a bit of a background in energy through my parents. My dad's been working in oil and gas for over 3 decades, and I've been exposed to how the energy sector works internationally for a long period of time. But I think as I was finishing up my undergraduate degree and really getting into the workforce, the climate movement definitely did not have the same type of momentum that we've seen it have in the last few years. But working in sustainability and working towards, what I see as society's biggest challenge in the 21st century, being climate change and associated carbon emissions, I think that has given me a lot more of a fundamental purpose, I think, than perhaps was the case with people working in energy or environment maybe 20, 30 years ago. We have a lot more data, a lot more knowledge about the changes that we're making to our planet. And trying to affect that in a positive way, I think, is quite gratifying, even when things are tough to do.
Absolutely. But tell me about the time, like, for instance, that you knew you wanted to dedicate your whole kind of career to this, right? The blood, the sweat, the tears, the energy you kind of put into it. What was that kind of moment and time? Can you remember it?
Yeah, it's a really good question. I think I would say there were probably 2 different occasions in my life where that really began to ring true. I would say early on, as an engineer, I felt very motivated by solving the technical challenge of closing the carbon cycle, trying to reduce our emissions from industrial sources and things of that sort. And I would say very early after I finished my engineering degree at Georgia Tech, that was a big driver for me, was the technical problem solving element of this very important and difficult challenge. In the last few years, I think it's taken on a much more serious meaning for me. About 6.5 years ago, I became a dad for the first time. I've got 2 kids now, and really seeing the implications of what we do now over the next 6 to 7 years leading up to 2030, and the impact that that's going to have on not just my kids, but all the generation of youth that's going to come into the world in the next 10 to 20 years. It really did give a deeper meaning and purpose to what we're trying to solve for at Carbon Upcycling. And I think, obviously now that we've grown our team quite a bit, we have many other young parents in the company. And so this has become more of a shared mission where, we want to be holding ourselves accountable in a few years' time to the impact that we're able to drive, and hopefully be a part of a much larger movement towards sustainability and circularity that obviously carbon upcycling is but one example of.
No, great. But tell me though, were you always, because you engineering, solving technical problems, right? I get the gist, right? That was what drove you. Looking back, the last 10 years, CEO of the business, well, number one of a startup company. Were you always an entrepreneur at heart? Do you think? Was this always how things were going to kind of work out when you reflect back?
My mom would joke and say it's probably because I wasn't easy to hire. So I probably couldn't have gotten a normal job. And so I had to start my own thing. But in all seriousness, this is my second startup. I did have a humanitarian focused startup before Carbon Upcycling. And I started that in my last year of my undergrad years. So I think in one sense, Simon, there has always been, I guess, a bit of a contrarian streak, I suppose, where I've been trying to see how we can solve problems and trying to do that within kind of the perspective of what we can do as a startup, as opposed to being a well-founded institution. There are a few different factors that probably play a role in that. I had to move around quite a bit when I was young. Like my parents left India when I was 8. I grew up in the Middle East, then moved to the States for my undergrad, and then to Canada after. So I've always kind of moved in my life. And perhaps that gave me a bit of a proclivity towards, starting my own ventures or trying to do things through unconventional means. But I would say there's also been more of a push toward new ventures and startups in the last 15 or 20 years. So it isn't maybe as abnormal as it used to be back in the day. But having said that, it absolutely has been gratifying. And I think personally being able to be fully accountable, not just for my segment of what I can solve, just with my training as an engineer, but also for all aspects of what success looks like. I think that's the part that I really enjoy. And ultimately in our culture is something we're really trying to imbibe as well. Because, ultimately, there are elements that will be solved by R&D. There'll be elements that are solved by engineering or HR or, good cultural practices and things like that. But ultimately, what you want is everybody in the team to take full responsibility for what we do. And in a sense, it's a microcosm of what we need to do around climate, really, right? I mean, as organizations, whether we are not-for-profits, government agencies, or corporations or startups, we all have to take accountability to a large extent for the system's results at the end. And frankly, right now is not the most exciting time. I mean, I would say there's reason to be pessimistic about how we're doing what we need to do. But I remain bullish that, hopefully things will come together quickly and we'll be able to ride this wave.
So there's a reason to be pessimistic with the way things look at the moment, but a cause for kind of optimism in terms of what we need to do together to create and solve to solve the problem.
I think so. I think resilience is what gives me optimism. But some of the short-sighted behaviors that we're seeing just in the last week, as an example, Simon, here in Alberta, we had a major carbon capture and storage project get canceled. It was, this multi-billion-dollar project that was really going to be one of the forerunners of essentially proving at large scale the type of carbon emission reductions that we can achieve at industrial scale. And, ultimately that got shunted down because of economic and financial reasons. But these are the type of things that, perhaps give us a bit of room for pause. But that's not to say that, there aren't other ways of alleviating the situation. And obviously that's one of the key drivers behind what we do at Carbon Upcycling.
Let's dive straight into kind of carbon upcycling. So, talk about the problems that you guys solve and why they're so important to you.
Absolutely, Simon. And, in a sense, the project that came down last week is an example of the contrast that we're trying to draw with what we do at Carbon Upcycling. So, if you really look at carbon capture and storage, especially when we talk about heavy industry, most of the focus in all policy think tanks and even massive kind of roadmaps to net zero that have been written up has been on carbon capture and storage, which is to capture the CO2 from a stack at an industrial site. It could be a steel plant, a cement plant, an oil and gas plant, an energy plant. And you essentially take that CO2, you capture it, and then you bury it underground where it can be stored for, thousands, maybe even tens of thousands of years away from our atmosphere, where it can really cause climate-related issues. And ultimately, it's a very elegant solution in the sense that, it is commensurate with the scale of the problem. So we can store a lot of CO2 underground, and that's very important because the problem we have is a massive one. We emit about 36 billion tons of CO2 from human activities around the world every year. The challenge with it is that there isn't necessarily an economic or kind of social value factor here apart from the long-term effects of climate change. And because our economic system currently isn't really tailored to tune for that, companies like Carbon Upcycling have been focusing on efforts where we can still sequester that carbon, but instead of burying it underground, actually use that carbon embedded material to make other industries that we rely on in modern society to be more efficient, more circular, and higher performing. And A couple of great examples of this that we've already done a lot of work on are within the cement and the steel industries, where, in cement, what we found is that we can take CO2 emissions from cement plants, take a range of different other solid byproducts of industries such as mining, steel, even kind of utility generation and waste management. And we can take the CO2 and these solid products, chemically combine them, and make an alternative to cement, or a partial alternative to cement, that is able to lower the carbon footprint of the final product and produce significantly lower emissions that you would get with how we make cement today. And so making this lower carbon cement with waste materials and CO2 has been a big driver of ours. And what we found is that by taking these waste materials from other sectors like glass or steel or mining, we're also able to help these industries reduce their emissions and reduce their environmental footprint, thereby helping all of these heavy industries kind of work together to create a more circular economy.
Yeah, it sounds so neat. So in essence, using CO2 as the feedstock to create kind of cement, as it were, new class of cements, as it were.
You're exactly right. The overall narrative around carbon emissions has always been that it's some sort of a waste that we need to dispose of. And in one sense, CCS is not very different from, when we build landfills for electronic waste or even frankly, nuclear waste from nuclear power plants and how that's stored away in Yucca Mountain and all these other places. Our overall kind of philosophy is that instead of treating this as a waste that needs to be disposed of, can we use this as a resource that can actually help enable the next wave of material science and improvements that we need to see in some of our most fundamental industries, of which obviously cement is an important one.
Yeah, no, great. So tell me a little bit about the milestones. It's been an incredible journey for you guys, right? So, in terms of where you are now, give us some sense of what that journey has looked like and what kind of key milestones you've really achieved.
Yeah, so like you said, we're just entering our 10th year in operation now. And for the first 5 or 6 years of Carbon Upcycling's history, we're very much focused on working in the lab, trying to work on this, what we call a dry or a semi-dry process to sequester CO2. So by and large, when you go back to your high school, middle school chemistry classes, all of the chemistry that we're exposed to happen in a little beaker with, water and a few colorful chemicals. The key innovation in carbon upcycling's work has been to enable that same chemistry of capturing the CO2 into waste materials, but doing it without any water use or minimal water use. And that has been critical for us because many of the plants that we work with, many of these industrial locations that we work with, are very much focused on dry chemistry. They want to stay away from water use because that's another environmental liability. Many of the cement plants in the world are in arid regions of the world. They do not have a lot of water access. And so if you're able to work in a dry or mostly dry process, as carbon upcycling's process is able to do, you have some distinct advantages in terms of the capital cost of your project and the economic viability of what you're doing. And I think over the last 9.5 years, what we've really focused on is, number one, proving that this can be done with a range of different materials, because to be truly global in cement, you have to be very, very local. It's kind of a paradox where, every single cement plant, even in a small country geographically like the UK, has 4 different cement plants, and each one of them has their own localized supply chain. And this gets exacerbated when you look at very large countries by landmass like, Canada or the US, where you've got, in Canada, you've only got 16 cement plants, but they're, all over the place. They're more than thousands of kilometers away. And so our first focus was to make sure that we can take families of materials that are available regardless of where you are in the world. You'll have some level of proximity to at least one of these families of materials. And secondly, just show that this can be demonstrably scaled in a way that is cost effective. And over the last 3 years in particular, Carbon Upcycling has done, we believe, quite an exceptional job in taking our technology from a lab scale, where we had a reactor that was no bigger than, kind of a coffee mug, and now scaling it up to where we're making 20 to 30 tons of carbon embedded, high performing cementitious material every day. And we're able to take that material into commercial projects where we've been able to get regulatory approvals and actually, do commercial projects with revenue, and most importantly, with proof of performance, which I think ultimately is what it's going to take to get this conservative industry to to change how they work.
Amazing. Tell me, you talk about the dry process. When you're kind of creating this, I'm taking it all the way back. Do you know straight away the target market you were going after? The application, the cement. Is that almost what's been on your mind the whole time, and then you're creating the process and the technology around that? Or is it the other way around? We're creating the technology and then let's find the market.
Yeah, Simon, you've obviously done a bit of research to ask a very pointed question. And what I would start by saying is it is definitely a very serendipitous process. When we started 5 years ago looking at cement, that was after having looked at many different applications of our technology. And we stumbled upon cement ultimately because we found that our process was scalable. And more importantly, we found that we could scale it cost effectively and in a way that would be adaptable to how cement plants currently operate. But for the first 4.5 years or so of Carbon Upcycling's existence, to answer your question, we weren't focused on cement at all. We were looking at a dry process still to carbonate or use CO2 to carbonate solid materials. But primarily it was because we're looking at novel applications in nanoparticles. We were looking at water filtration and energy storage and even pharmaceutical drug delivery. And some of these angles are still in play today. We continue to fund research to kind of move those along. But primarily, I think the big realization for us was that whatever solution we come up with for carbon sequestration or carbon utilization, it has to be a scalable solution. It cannot be something that creates a change at the hundreds or thousands or even hundreds of thousands of tons of emission reductions a year. That's just not meaningful enough. We have to have something that can achieve impact at billions of tons of scale. And when we got into an accelerator program that at the time Lafarge Holcim ran in France, we were able to get the initial proof of concept that we needed to say, we can adapt what we've got now, we can tailor it, at least fundamentally, for use in cement and building materials. And it took us about another 2 years to really figure out how. But once we did that, we started rapidly scaling up, and here we are today.
I was going to say, what's more enjoyable, the scaling or the working out the how bit for you, the 2 years solving the problems in the first place?
It's a really good question. I would say they're equally painful. I think there's, I used to play video games when I was in my teenage years, Simon. And, one of the things I really miss about my childhood is just how instantly you could achieve gratification. So like the how of solving a mission or getting through a level or a campaign in a real-time strategy game, you could do that in about an hour or two and feel like you've accomplished something. I think the most challenging thing in both the scale up and the problem solving bit is the wait, because you kind of have a couple of hypotheses. You might be down a certain track and it'll take you literally months to figure out if you're on the right track or not. And, I read The Lean Startup by Eric Ries probably about 9 or 10 years ago, right around the time that we founded Carbon Upcycling. And, he talks about the rapid iterations and how you have a minimum viable product and then you quickly iterate to see what's working and what isn't. In climate tech, even more so than in other hard tech, this iteration can take months, sometimes years. Whereas, in a software play, you can probably get a beta out and get feedback from customers within a couple of weeks. And so that staying power and being able to stay patient and persistent while you're waiting for things to happen, I think is the toughest part. And it brings me to a quote actually from Edison that I really like. He talks about how, they win who hustle while they wait. I think ultimately to succeed in climate tech, it's something that I have to keep reminding myself and our team about, because if you can't keep that momentum going and work on other things while you're waiting for a few other, few of the balls that are in motion to bear out, you're quickly going to lose motivation and not be able to stay for the decade or 2 decades that you need to achieve real impact.
Yeah, no, thanks for sharing. And no, there's all sorts of things to discuss around it. I'm thinking like from the technology viewpoint, I think first of all, the actual innovation itself, and are these processes which you're patenting and you can protect yourself when it comes to protection, I suppose, yeah.
Yeah, what I would say is primarily, I think the big fundamental shift that we're trying to drive, and it is happening in cement more broadly as well, is people are looking at this family of materials, Simon, called supplementary cementitious materials. So these are materials that act and behave like cement, but only when they're mixed with the cement in the first place. So, what we call cement in the normal world today is primarily limestone that's been baked at 1,500 degrees Celsius. And when it's baked, it gives off a lot of CO2. And what you're left behind with, the calcium oxide, makes up the heavy majority of our cement. And so for every ton of cement that we make today, by and large, we're emitting about 700 to 800 kilos of CO2. And if you're able to take this SCM material, so these materials like ashes or clays or steel slags, if you're able to activate these materials to have enough reactivity, you can make a cement, a blended cement, where it's 1 part clay, let's say, or 1 part, slag, and it's 1 or 2 parts normal cement. And you can drive up to 50% cement emission reductions on a per ton basis. And this overall blending approach, essentially blending cement with materials that actually absorb CO2 as opposed to emitting CO2, is the crux of what we're really trying to achieve. And, there is already a lot of innovation that suggests that this could potentially drive, cement emissions down from that 800 kilo per ton number all the way down to 400 or even 300 kilos per ton if this technology is fully kind of, scaled. And what carbon upcycling is trying to do is couple this with the other challenge that the industry has, which is that right now, these materials that the industry uses to decarbonize perversely come from industries that are already very carbon intensive. So for example, a lot of the blended cements that are produced in Europe use blast furnace slag from steel blast furnaces, which only work with huge amounts of coal combustion. And so as the steel industry is electrifying, this slag resource that the cement industry has been using for the last 30, 40 years is disappearing, and their ability to decarbonize or keep their product at a lower carbon footprint is diminishing. And so with a technology like carbon upcycling, you're able to take electric arc slag. So this is a slag that you would produce as you electrify your steel industry. In our perspective, this is the virtuous kind of direct relationship you want. You want cement to decarbonize more effectively as the steel industry decarbonizes, not the other way around, where, the cement industry is actually hoping that the steel folks decarbonize slowly so that they keep getting this cheap feedstock that allows them to claim their carbon credits. And so I think ultimately, if you look at kind of the patent portfolio that carbon upcycling has built, we've very much been focused on not just the CO2 sequestration angle, which is obviously a key part of our carbon upcycling story, but also on the solid waste upcycling part, where, these local wastes that otherwise have very kind of de minimis uses, if any, can be upcycled as well. And that allows you to get cheap materials and sequester CO2 to make a fully upcycled solution that can decarbonize cement.
Yeah, and great. And what about the performance of the material vis-a-vis the incumbent material? Are there any differences?
Yeah, it's a really good question. And as you can imagine, for any of these industries, like with cement or steel, you're going into major infrastructure and you want to make sure that the performance is never compromised as you're taking on new technology. And so over the last 3 years, with the commercial scale pilot units that we've had running in Calgary now for 2 or 3 years, we're very much focused on getting as much data as possible with the field deployments to show that from a durability, stability of a final product, strength evolution perspective, that these materials actually work just as well, if not better, than normal Portland cement, which is the conventional cement that we use. And generally what we found, Simon, which has been interesting, is that people talk a lot about Roman concrete and some of this stuff that was built 2,000, 3,000 years ago and has stood the test of time. A lot of the reason behind that is chemically, these materials, or the materials that we used back in the day, were significantly less calcium rich than the cements that we use in modern infrastructure. And so one of the things that happens with any SCMs, and definitely with the ones that carbon upcycling is promoting, is that we're reducing the calcium content of the cement, which in turn allows it to be more sustainable and durable. And in our view, one of the big challenges that all civil engineers and architects are going to face over the next 30 to 50 years is, how do we build more kind of low carbon infrastructure and still have it be climate resilient? Because really, if you look at the frequency at which 1 in 100-year events are happening, you'd almost make the case that we need our slabs and our sidewalks and our bridges to be thicker and bigger. which would exacerbate their carbon emissions. But really, the only fundamental way of changing this balance is by creating more lower carbon, higher resilient, kind of durable structures and chemistries. And we're hopeful that over the next few years, as we continue to do more work in the field, we'll show that carbon upcycling is one of the great ways of doing that.
Amazing. Thank you for that. Really, good to know. Tell me, so where you are now, obviously really exciting times. So talk to me a little bit about the future and about the scaling process, for instance, and what that looks like.
What we've been able to prove so far, Simon, is that the technology works as a standalone unit. So we've been able to use a carbon capture demonstration facility in Alberta to show that we can take flue gas directly from a CO2 source. So instead of necessarily needing carbon capture on a flue stack that's emitting carbon emissions and pollution, we're able to plumb that right into our unit, use the CO2 from that source, and make a low carbon cementitious product. Our next challenge is to show that we can do this at a cement plant. There is about 3.5 billion tons of emissions that come from the cement industry every year. 80% of these emissions come from just 3,000 cement plants in the world. These are the hubs that make up the building material infrastructure in any major city, any growing economy in the world. And so over the next couple of years, our main objective is to show that we can plug into at least 2 of these plants. We've got one plant in Eastern Canada and another plant in the UK, in the Midlands. And with both of these locations, we want to show that we can take 2 different types of feedstocks. We can chemically activate them to lower the carbon emissions right at the source, right at one of these 3,000 cement plants. And as we prove that out between now and the end of 2025, our view is that we'll be in a prime position to then really tackle that 80% of the emissions that comes from these places right at the source, instead of having to worry about liquefying the emissions and transporting them, which obviously comes with its own parasitic, energy losses. And I think once we're able to do that, that'll be an inflection point at which hopefully we can start moving tangibly towards our aspiration of being a bolt-on solution at every single plant. And if and as new cement plants are being built between now and 2030 and definitely leading up to 2050, the carbon upcycling solution is part of the package from day one, because people realize that this is a way of creating a new cement plant that already from day one emits 30 to 50% less carbon than a plant that has been built over the last 200 years.
Yeah, got you. Well, what do you see are the biggest challenges you face in terms of you realizing this vision?
I would say there are 2 big ones, Simon, that come to mind. Number one, I would say is, there's been a lot of focus in the recent past around how to finance carbon capture and carbon sequestration projects. Carbon utilization hasn't necessarily been getting the same type of attention from policy and even from multinational think tanks. I think that really has to change, because carbon to value projects, carbon utilization projects need as much project finance support at the early stage as do large scale carbon capture and storage projects, which bury the CO2 underground. And to us, there's been almost a hyper focus on the latter and not enough on the former. And so we would love to see that change, and more project financing opportunities to scale the first of a kind, the second of a kind. Those first 10 or 15 projects is going to be key. And we're seeing some early movement there, but it can definitely be faster. And I think the second piece is going to be building up the type of, human resources that we need in these companies to scale in the way that we need to. If you look at what happened in the petrochemical business in the early 1900s or even the late 1800s, there was a huge focus on building up massive refineries. And there was enough technical experience to go around that even now, 100, 150 years later, there's an entire industry of professionals that's built around taking care of these massive infrastructure projects, right? Like, say what you want about oil and gas, but one thing that everybody can learn from them is how to build large projects and keep them running nicely. And, that's one of the things that climate tech needs to learn is, how do we get these projects, these pilots, these large scale, first of a kind commercial demos to run really effectively, reliably, like industrial pieces of equipment. And I think it's going to need new technology, but it's also going to need old experience. And it's going to need all of this to come together in a very short period of time. I mean, I think, it needs to happen between now and 2035. And from my perspective, one of the things I'm really excited about at Carbon Upcycling is building those project development teams. Not necessarily because I, as a chemical engineer, can offer too much value once the mechanical and the civil guys get involved, but more because, if we can build these teams that have this track record of building these projects successfully, in my personal view, that creates kind of that first domino, which hopefully then, rolls the next few hundred.
Yeah, the challenge, for someone that's hired for companies in the space for these first of kind projects, I always find the challenge is just someone that's done it at an early stage, someone that's done first of a kind. There's always kind of someone that's worked within a broader, larger facility that's already there, as it were. That I think from a human resources perspective, would you agree that it's that kind of challenge of roll your sleeves up, hands on, doing it for the first time in quite a unique environment, right?
I think you're exactly right. Like, that's one of the big things we see is that, sometimes you find the people that could be your master builder for a project, right? Like, they are the people that have got that experience. But if they did that 20 years ago and now they're at a stage of their career where they've been managing project teams with a few hundred or 1,000, crew members, they're no longer at the stage of their career where they can go back to the experience they had 20 years ago building, a petrochemical plant or a combined cycle energy plant or renewable plant even. And, again, there is a huge amount of similarity between building a carbon capture project or a carbon utilization project to building a cement plant or an energy plant, in the conventional sense, like a petrochemical refinery or a combined cycle natural gas plant, rather than something that's more modular, like a solar installation or a wind installation. And, many of those kind of latter type of projects tend to be more electrical heavy. Everything we do at Carbon Upcycling, a lot of what direct air capture does, carbon capture and storage does, is mechanical, it's chemical, it's, process. And so those type of skill sets, unfortunately, are not the ones that we can leverage from the renewable energies sector's kind of, tremendous success over the last 15 years. So you're exactly right. I think finding those people that are able to kind of, traverse both those worlds of rolling up their sleeves and doing the job, but then also doing mega infrastructure project deployment, it's a rarity. And I think the few companies that are able to do this are ultimately the ones that, in my opinion, are going to be successful.
Yeah, no, absolutely. And I know you guys, I think you've grown from 6 to 34 people, something along those lines over the last few years. So you're clearly on a real growth trajectory. So I suppose a couple of questions. First of all, tell us about the culture you've built and are growing there. What's it like to work at Carbon Upcycling?
Yeah, I mean, as you can imagine, I'll probably have a bit of a biased perspective, having been at the company since the start and I guess being one of the older hands. But I think there were two things that really stick out to me, especially with the year we had last year, where, we, to your point, like grew our headcount quite a bit. Like, we're now at 42 full-time equivalents at Carbon Upcycling. We were at 34 at the beginning of the year. And, we've grown by, I think, 16 or 17 people last year. And just in this first quarter of this year, Simon, we've grown by another 9 people. And so as these people are growing in, especially with the stage that we're at, every new personality adds a bit more of a unique dimension to the company and, can either further amplify the culture build out that you're trying to do or severely hamper it. And what I found is that the mission-driven part of what we do is really important. And sometimes the mission isn't necessarily, aligned with the vision. What I mean by that is, some of us do get up and think about, where we need to be by 2030 in the macro sense and the role Carbon Upcycling plays within that. I think my role as founder is to make sure that I keep refining that vision, keep reiterating it and evangelizing it to a certain extent. But for some of the newer members of our team, some of them are just coming out of university. I mean, they're not thinking in those kind of ways, right? And so for someone like that, I mean, the mission could be, where do they want to be in their career in 5 to 6 years? What type of skills do they want to learn? What type of management or kind of collaborations they want to build, relationships they want to build? That has been a key lesson for us, is to kind of bridge both of those and make sure that people are getting what they need at the stage of the career that they're at. And I think the second thing is consistency. It's really, really important, as we grow from, the people that built our first commercial scale unit back 3 years ago, there was only 12 people in our team at the time. There was a much more collegial culture at the company at the time. And, we were all friends. We could all text each other at Friday night and, see what was going on, even if it wasn't related to work. Obviously, you can't do that once you get past, 30 odd people or whatnot. And so within that, I think staying consistent to what are the values and being really, really succinct with them, and especially having the leadership really embody that as much as possible, I think has been a key lesson. And frankly, we haven't done it well all the time, but we try to do it correctly most of the time. And I think, again, going back to your question from earlier about what's the tougher part, is it scaling or is it solving the how? I would say the how of people has been absolutely, one of the biggest challenges and learnings for me, because it hasn't been something that, I ever got taught at school. And I'm essentially learning on the job. But I think so far getting the right people around us has been very gratifying.
No, great. So if you were giving some advice to a climate tech CEO that was doing it for the first time and they were just about to scale, what would you say about getting the people equation right? What could you impart on them from your learning perspective?
I think there can be a tendency sometimes for us to overrate experience over motivation and energy. And I would say really striking the balance where maybe it's, 60, 70% towards energy and motivation and drive, and maybe 30 to 40% towards, the right experience would be the way I would put it. And it goes back a little bit to the question you asked about, how we build project teams, Simon, because I think one of the challenges that you can have is that if you go too heavy on the right technical experience right at the start, you might start already with a set of practices that are not well suited for how you need to run a startup. And so being mindful of that. When I say experience versus energy, I don't necessarily mean from a years of experience in the field or something like that. And I definitely don't mean that 20-year-olds coming out of university have a lot of energy. It definitely isn't mutually exclusive. But what I would say is that sometimes there is that notion of faking it till you make it. And sometimes that can mean you get the senior vice presidents of XYZ companies on your advisory board, your leadership team, and you're like, look, these guys did it 30 years ago. They'll do it with me. I'm set. That can, in my limited experience, be a mistake. I think you're better off, making sure you focus on the values, you focus on what you really need to drive to get done. And once you've got the momentum going, that experience can be extremely helpful. But if you get it in too early and it ends up hampering your momentum, you probably already started off on the wrong foot.
Thank you for the advice. I think you're absolutely spot on. Sometimes the tendency when you're hiring is you almost go the other way. You want X, Y, and Z. You want to de-risk yourself. So you think by hiring the X, Y, and the Z and everything else, right, I'm going to take the risk out of the equation.
In a sense, you're chasing the title and the previous work, not what the future work is going to be. And I think keeping your eye on the future work and what you can see get done in the time frame and the budget you've got. I don't know if that's a good way of rephrasing what you said, but that's the way I'm thinking in my head. Is I think you really have to be critical looking forward, not giving too much precedence to looking back. Though obviously it's foolish to not give any, right?
Yeah, absolutely. Look, I could talk to you all day about this, but I know you've got a company to get back on and do lots of stuff with over the coming weeks and months. So just wanted to say thanks so much. Really enjoyed the conversation. Really enjoyed having you on the show. And, we'll be following you and just wishing you all the best for the future.
Thanks so much, Simon. It was really fun as well. And I look forward to keeping in touch.